Hey, this is Tim from Tiger Astronomy, and the observatory's been busy tonight, and just in between showers of rain, it's detected clear skies and opened up and observed some more of our asteroids for us, which is superb. This is really the benefit of a automated robotic observatory, is that it can just, whenever there's a little bit of clear skies, just open up and start doing stuff, which I guess a lot of astronomers would have looked out the window this evening and saw the rain and thought, meh, and gone to bed. But our observatory's been active and catching asteroids, so you can see that we've had some observations for 433 Eros, and down here we've got 532 Herculina, and down here 704 Interamnia. And this one, 454 Mathesis, is running, and it's been interrupted by weather. And the observatory's closed down with only 2 images taken, so there are still 2 to go on that one. It's 50% complete. So, and these other ones are deferred, which means they never got to run. They were in the queue, but they probably hadn't risen high enough, I would guess. We can drill into that and see that. Yes, it's pending, and I guess we can look down here in the project at, what is it, 451 Patientia. That's this guy here. So if we go into there, and it tells us, right, deferred until 2248 UTC, so that's actually eligible now, but because the weather is pretty pants at the moment, we're not going to see anything. So let's just switch over to the observatory control window. Excuse me. And actually I think it's already open here. There we go. You can see it's cloudy and the shutter's closed and the dome's parked and everything's stopped and the scheduler is asleep. So maybe we'll get some more tonight, but right now we've got what we've got, and here's one of them opened up in Maxim DL, and this is actually the 4 observations for, I think, Interamnia, I think. Now you can, in Maxim DL, you can animate images, so you just use your animate thing here, you add all the images you want to animate, and like that, and we say OK, and we start the animation playing. And okay, so you might think there's a way you can blink asteroids, but as you can see, because the telescope has tried to follow the asteroid, the star background's moving the whole time, and we can't really sort of pick out the asteroid from in this image. I think it's that one there, but it's just hard to see. So we could take the trouble to align these images and then animate them again, and then we'd see the asteroid moving against a static star field. But actually it's just easier to use visual pinpoint to do it. So I've got all tonight's images already loaded in visual pinpoint here, so I'm going to plate solve them, and that will just take a few seconds. You notice that it's not having to download the catalogue files tonight because that was already done before, and so it's OneDrive has cached them locally. So they're in my working set now. And they're all plate solving fairly well. And we should get a report up in a text file, which will come up in Visual Studio Code because that's my text editor. So, okay, so 426 image stars found, 1,328 catalogue stars found. They're quite hazy images, so that's not surprising. So, but they are solving good enough, and if you want the details you can drill in there. I'm not going to worry about that. I'm just going to go straight on to find asteroids, get solved. So there they are, and you notice that Visual Pinpoint has carved them all up into groups for each different object based on the object coordinates from the plate solution. And we can now just hit find asteroids. And away we go, and this is our first match. And this is Eros, and it's quite a fast moving object, and Pinpoint's had no trouble finding that straight away. And so we can accept that and say that we want to report it, and we're done. And up comes the next one. And okay, so this is interesting. Now this is this is the asteroid here. You can see it moving, especially in the magnifier window. You can see it's moving image to image. It's a slow moving one, this one. And so I think I may have my detection settings a little bit aggressive in Pinpoint, and it's not moving far enough to Pinpoint to detect automatically. So we can just go ahead and click on it to stop the animation, and then click again to select the object, and then step to the next plate, click the object again, next plate, object again, and the next plate, and the object again. And notice I'm clicking slightly off center here deliberately, and Pinpoint actually finds the centroid of the object and selects that for me. And so yeah, we'll report that, and there it is. Awesome. There's that little galaxy there again, and there doesn't seem to be any other objects in the image apart from a few cosmic ray hits and things. So we're done with that, and this one I think is Interamnia. Yep, Interamnia. So again, quite slow moving, but Pinpoint's had no trouble at all detecting it. I can't see anything else moving in that image. Pinpoint can't either. Interestingly, it thinks this is an NEO, a near-Earth object, near-Earth orbit. Which I'm not sure if that's right or not, but anyway, we'll accept that and report it. And we will say done, and that's all the ones we've got tonight. And then up comes our report for the Minor Planet Center. Now, I think we've got enough now to actually send off. I think we only need 2 nights worth of observations, and we can send off for our observatory code. Now I'll wait a little while to see if the observatory opens and takes any other objects, but otherwise I think we've got enough data there to put in a report to the Minor Planet Center, so that's the next step. So I'll come back to you when that's done. I've been Tim from Tigrit Astronomy. Thanks for watching, and goodbye.